Our next guest is an 8th grade physics teacher from Queen Creek who recently won a national microgravity competition for educators. The honor comes with the opportunity to ride and do research in a weightless flight lab. We welcome Sossaman Middle School teacher Nancy Foote. Congratulations on the award.
Thank you.
Look at you getting it. Now, this was a competition for educators. What was your and your classroom's presentation?
Well, we had to make a video, less than 3 minutes, which was difficult, saying what we would do if I received a zero-G flight, what experiment we would run. And we decided to look at some toys and see how they would react with microgravity. And we wanted something that any classroom, whether you were a kindergarten classroom or a high school classroom, could do in gravity and then predict what would happen if those same toys were used in zero gravity.
So show the relationship of something here on Earth, regular gravity,
right,
and then in microgravity, in space or even further out.
Yep,
All
absolutely.
right. So to win this contest, you've got to present and got to get their attention. You got it, and you won. Yeah. The result is you get to fly in what, a flightless lab?
Yeah. Isn't that exciting?
Yeah, it is.
Yeah, it's very exciting. It was very difficult for my students to come up with just a few toys. They had to come to consensus, which is difficult. I mean, imagine you're a 13-year-old student and your teacher says, here's these toys, now agree on which ones we're going to take on a zero-G flight and agree on what's going to happen. Very difficult.
All right, so we got the toys with us here on set. Let's get started with these, because these are what you're going to take into this flightless lab, and we're going to find out what little, if any, gravity does. The first one is what, the Newton's yo-yo. What is that?
Newton's yo-yo. Okay, this is a yo-yo that actually is going to show two of Newton's laws. Newton's first law says, basically, an object at rest stays at rest unless acted on by an outside force. So I'm going to stand up for this. Is that okay?
Do. Yes.
Okay. So this ball on the bottom is going to stay there until it's acted on by an outside force. Now, I'm not magically changing the color of the bottom ball. I'm actually making the one ball hit it. That's one law. The second is the action-reaction.
Gotcha.
And so my students think that gravity's not going to impact this at all. It's just going to be easier to use it when there's no gravity.
So it'll go slower?
Nah, they think it'll go faster.
It'll
be easier, that I'll have to work less hard to make it move.
Wow.
So we'll see.
I was going to say, what do you think?
They're probably right. Yeah, and I'll also have the opportunity to do a Martian gravity and a lunar gravity, a moon gravity also, so that will give us some good data.
Interesting. All right, so that's the Newton's yo-yo. We also have something called self-siphoning beads. What are those?
Beads. These are like those beads you used to put on your Christmas tree, and they're very wonderful. They're very amazing. They don't behave very well, though. They don't like to behave. So basically, you ready?
Yes.
Okay. And that's it.
Okay, that's it here. So, what's it going to be like with no gravity?
We're going to find out, and that's very controversial among my students. Some think it's going to be just the same. Lots of them think it's going to form a big cloud. Some think it's going to stay in the cup. I have my own opinion, but I refuse to tell them what I think is going to happen, because when a teacher tells kids what they think is going to, then every kid thinks the same thing as the teacher, right? So I'm not going to tell them. I will tell you that gravity impacts the initial pull and the initial fall, but after that it actually works as a little pivot. 3 of the beads act together and it pivots kind of like a teeter-totter.
Yes.
So we'll see what happens.
Wow, because my thought would be, I'm not one of your students here, so I can just go and throw this out there. Yeah, I just think it's going to fly all over the place.
Yeah, that's what they think too.
Yeah.
And it'd be wonderful, wouldn't it?
Yes.
When you're in the microgravity part. But remember, every microgravity is followed by a 2 or 3G at the bottom, which means it falls on you. Anything that's up there floating around, you get nailed at, when you're in the
you got to bob and weave and got to avoid things. All right, so that's a self-siphoning beads. We also have something called you got them right.
Jitter
what
rings.
Is a jitter ring?
Jitter ring. These are like little washers around a big ring, and that's how they work. Isn't that the coolest thing in the world? It's so intriguing. These are the kinds of things I have in my classroom when I want the kids to just ask questions and investigate and try to figure out what's going on.
What is going on?
I don't know. I mean, it's centripetal force, I know that for sure, but the faster you turn it, the more they go. And all I can tell you is I know that gravity keeps these rings towards the bottom.
Right.
Without gravity, I suspect that they would still go around this silver ring, but they're not going to hang around the bottom. So I think they're just going to get in the way of my hand.
Are they still going to jitter?
I think so. What do you think?
I don't know.
But what do you think?
I think, you know what? I don't think they're going to jitter. I think
Okay, you don't think
they'll
they'll jitter.
jitter more slowly.
Okay, maybe you're right. We'll have to find out. See, that's the beauty of these things, is really whether you're an adult or whether you're a child, we don't know for sure. Even as scientists, I've spoken with all kinds of scientists, they don't know either. And that's the beauty of this. We really don't know. It's not like somebody has the answer out there and they're waiting for us to just pick the right answer. That's why I'm so excited about going on the zero-G flight.
Well, and we can tell by your excitement. We can feel the
excited.
excitement. Go ahead and take a seat again
Thanks.
now. So you're taking all this thing into this flightless lab. You won the flightless lab because you won the doggone contest.
Yeah.
Congratulations
Yeah, thank
on
you.
that. What got you, because you have a background now in science, don't you? You haven't always been a teacher.
No, I was a chemist originally. I was a chemist.
What got you into teaching?
I had children, and I realized that money wasn't everything. And when I made a list of every job I've ever had, this is like 32 years ago.
Yeah.
I thought, what do I want to do with my life? And I made a list of every job I've ever had, and ranked them from 1, meaning I would never do this job no matter how much money they paid me, to 10, meaning if I had to pay to do it, I'd still want to do this job. And I looked at it and I went, it says I want to be a teacher. I don't want to be a teacher. I guess I want to be a teacher.
Yeah.
So I started being a teacher.
But you're teaching things that you are interested in. And that helps a whole lot, doesn't it?
It really does. Yeah. And I'm in year 32, and I can't imagine not doing it.
Oh, so and congratulations again on winning this. Now, when are you going to go into this flightless lab thing?
Tentatively scheduled for August 17th. I'll fly out of Houston.
Okay. So, boy,
Isn't that exciting?
It is exciting.
I know.
And now, once you get all this done, it's going to be chronicled in some way, shape, or form. You bring that back to the classroom and you show the kids and say, here, you bunch of kids, here's what I did. Yep. Here's how gravity works, and here's how microgravity works.
Yep. And we talk all the time in physics about everything has to be done in the imaginary physics world, because we live in a world that's so grounded in gravity and in friction that I tell them, now imagine there's no gravity, no friction, no air resistance. You really can't.
But you will be able to see
now. But now we'll be able to.
Well, Nancy Foote, Sossaman Middle School, congratulations.
Thank
I can tell you're a fantastic teacher. Good luck on that ride, too.
I appreciate
Sounds
that.
like fun.
It will be.
Thank you.
Thank you.